According to the current National Electrical Code, the service entrance conductors must be sized for the calculated load or 125% of the highest demand load, whichever is greater. The National Electrical Code requirements have changed over time. The code in effect at the time the house was built would determine the legality of the original installation. However, it would likely need to be upgraded to current standards if major renovations or changes are being made. The calculated load of 207 amps exceeds the capacity of the existing 200 amp service. The 2/0 copper conductors used for the service entrance are sufficient for a 200 amp service but may not be large enough for a 320 amp service. The use of a gutter to distribute power to the panels is not typically permitted by the National Electrical Code. Based on the current load and the National Electrical Code requirements, it is recommended to upgrade the service to a 320 amp service. This would involve firstly, installing new service entrance conductors rated for 320 amps. Secondly, replacing the gutter distribution system with a more appropriate method, such as a subpanel fed by the main panel. Thirdly, upgrading the main panel to a 320 amp panel. When evaluating an electrical service, several key factors must be considered to ensure safety and compliance with the National Electrical Code. These factors include the service entrance conductors, the distribution system, and the overall load calculation. The service entrance conductors are the wires that bring power from the utility company's transformer to the main disconnect of the building. Their size must be adequate to handle the calculated load of the building, with consideration for future expansion. The distribution system refers to how power is distributed from the main disconnect to various branch circuits throughout the building. This system must be designed to minimize voltage drop and ensure that each circuit receives the proper voltage. The load calculation is a critical step in determining the appropriate size of the service entrance conductors and the distribution system. It involves adding up the anticipated loads of all electrical devices and appliances in the building, with allowances for diversity and future growth. In older homes, it's common to find electrical systems that were installed according to the codes in effect at the time of construction. However, these systems may no longer meet current code requirements due to changes in technology and increased electrical demand. One common issue is undersized service entrance conductors. As homes are renovated and new appliances are added, the electrical load can increase significantly. If the service entrance conductors are not large enough to handle the increased load, they can overheat and pose a fire hazard. Another common issue is outdated distribution systems. In some older homes, power is distributed using a gutter system, which is essentially a metal trough that houses multiple conductors. While this method may have been acceptable in the past, it is no longer permitted by the National Electrical Code due to safety concerns. When evaluating an electrical service in an older home, it's important to consider the following steps. 1. Perform a load calculation to determine the current and anticipated electrical load of the building. 2. Inspect the service entrance conductors to ensure they are properly sized for the calculated load. 3. Evaluate the distribution system to ensure it meets current code requirements. 4. Identify any potential safety hazards, such as overloaded circuits or damaged wiring. If the electrical service does not meet current code requirements or if any safety hazards are identified, it's recommended to upgrade the service. This may involve replacing the service entrance conductors, upgrading the distribution system, and installing new overcurrent protection devices. When upgrading an electrical service, it's important to work with a qualified electrician who is familiar with the National Electrical Code and local electrical codes. The electrician can assess the existing electrical system, perform a load calculation, and recommend the appropriate upgrades to ensure safety and compliance. Upgrading an electrical service can be a significant investment, but it's a necessary one to protect your home and family from electrical hazards. By taking the time to evaluate your electrical system and make any necessary upgrades, you can ensure that your home is safe and up to code. When assessing an electrical system in an older home, it's crucial to understand the historical context and how electrical codes have evolved over time. What might have been considered acceptable practice decades ago may now be a violation of current safety standards. This is why it's essential to have a qualified electrician evaluate the system and determine if any upgrades are necessary to bring it up to code. One of the most significant changes in electrical codes over the years has been the increased emphasis on safety. Modern codes incorporate numerous safeguards to protect against electrical shock, fire, and other hazards. These safeguards include requirements for ground fault circuit interrupters, arc fault circuit interrupters, and tamper-resistant receptacles. Another important change has been the increased demand for electricity in modern homes. As technology has advanced, we've become increasingly reliant on electrical devices and appliances. This has led to a corresponding increase in the electrical load on our homes, which can strain older electrical systems. When evaluating an electrical system, it's important to consider the following factors: the age of the wiring, the type of wiring, the condition of the wiring, the size of the service entrance conductors, and the capacity of the electrical panel. Older wiring may be brittle, cracked, or otherwise damaged, which can increase the risk of electrical shock or fire. The type of wiring is also important to consider. Aluminum wiring, which was commonly used in homes built in the 1960s and 1970s, has been shown to be more prone to overheating and causing fires than copper wiring. The size of the service entrance conductors must be adequate to handle the electrical load of the home. If the conductors are too small, they can overheat and cause a fire. The capacity of the electrical panel must also be sufficient to accommodate the number of circuits in the home. If the panel is overloaded, it can trip breakers and cause power outages. In addition to these factors, it's also important to consider the overall condition of the electrical system. Are there any signs of water damage, corrosion, or other problems? Are the receptacles and switches in good working order? Are there any exposed wires or other safety hazards? If you have any concerns about the safety or condition of your electrical system, it's best to consult with a qualified electrician. An electrician can perform a thorough inspection of the system and recommend any necessary repairs or upgrades. In the specific scenario described, the existing electrical service appears to be undersized for the current load. The calculated load of 207 amps exceeds the capacity of the 200 amp service. Additionally, the use of a gutter to distribute power to the panels is not in accordance with the current National Electrical Code. Therefore, it is recommended to upgrade the service to a 320 amp service. This would involve installing new service entrance conductors rated for 320 amps, replacing the gutter distribution system with a more appropriate method, such as a sub-panel fed by the main panel, and upgrading the main panel to a 320 amp panel. It is important to note that electrical work can be dangerous and should only be performed by a qualified electrician. When planning an electrical upgrade, it's essential to obtain the necessary permits from the local building department. This will ensure that the work is performed in accordance with all applicable codes and regulations. The permit process typically involves submitting plans to the building department for review and scheduling inspections to ensure that the work is done properly. Obtaining permits may seem like an unnecessary hassle, but it's an important step in ensuring the safety and quality of your electrical work. In addition to obtaining permits, it's also important to choose a qualified electrician for the job. Look for an electrician who is licensed, insured, and experienced in performing electrical upgrades. Ask for references and check online reviews to get a sense of the electrician's reputation and quality of work. A qualified electrician will be able to assess your electrical needs, recommend the appropriate upgrades, and perform the work safely and efficiently. They will also be familiar with the local electrical codes and regulations and will ensure that the work is done in compliance with these requirements. Upgrading an electrical service can be a significant investment, but it's a necessary one to protect your home and family from electrical hazards. By taking the time to plan the upgrade carefully, obtain the necessary permits, and choose a qualified electrician, you can ensure that the work is done safely and effectively. In older homes, electrical systems often present unique challenges due to outdated wiring methods, undersized components, and a lack of modern safety features. When evaluating an electrical system in an older home, it's important to consider the following factors. Firstly, wiring type. Older homes may have wiring systems that are no longer considered safe or up to code. For example, knob and tube wiring, which was common in homes built before the 1940s, is ungrounded and can be a fire hazard. Aluminum wiring, which was used in some homes built in the 1960s and 1970s, can also be problematic due to its tendency to corrode and overheat. Secondly, service capacity. The electrical service capacity of an older home may be inadequate for modern electrical demand. As we use more and more electrical devices and appliances, the electrical load on our homes has increased significantly. If the service capacity is too small, it can lead to overloaded circuits, trip breakers, and even electrical fires. Thirdly, grounding. Grounding is an essential safety feature that helps to protect against electrical shock. Older homes may have inadequate or non-existent grounding systems. This can increase the risk of electrical shock if there is a fault in the electrical system. Fourthly, overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect against overloads and short circuits. Older homes may have outdated or undersized overcurrent protection devices, which can increase the risk of electrical fires. Fifthly, National Electrical Code compliance. Electrical codes are constantly evolving to improve safety and address new technologies. Older homes may not be in compliance with current National Electrical Code requirements. This can create safety hazards and make it difficult to sell the home. When evaluating an electrical system in an older home, it's important to have a qualified electrician perform a thorough inspection. The electrician can assess the condition of the wiring, the service capacity, the grounding system, and the overcurrent protection devices. They can also identify any potential safety hazards and recommend the appropriate repairs or upgrades. Upgrading an electrical system in an older home can be a complex and costly project, but it's an important investment in safety and peace of mind. By addressing the issues mentioned above, you can ensure that your home is safe, up to code, and able to meet your modern electrical needs. When dealing with electrical systems, safety should always be the top priority. Electrical work can be dangerous and should only be performed by qualified and licensed professionals. Attempting to do electrical work yourself without the proper training and experience can put yourself and others at risk of electrical shock, fire, and other hazards. Before starting any electrical project, it's important to disconnect the power to the circuit or device you'll be working on. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Always double check to make sure the power is off before touching any wires or components. When working with electrical wires, it's important to use insulated tools and wear appropriate personal protective equipment such as rubber gloves and safety glasses. This will help to protect you from electrical shock and other injuries. Never work on electrical systems in wet or damp conditions. Water is a good conductor of electricity, and working in wet conditions can significantly increase the risk of electrical shock. If you're not sure how to do something safely, it's always best to consult with a qualified electrician. They have the knowledge and experience to perform electrical work safely and in accordance with all applicable codes and regulations. In addition to following these safety precautions, it's also important to be aware of the potential hazards associated with electricity. Electricity can cause serious burns, shocks, and even death. It's important to treat electricity with respect and to take all necessary precautions to protect yourself and others from harm. If you ever experience an electrical shock, seek medical attention immediately. Electrical shock can cause internal injuries that may not be immediately apparent. It's also important to have your electrical system inspected regularly by a qualified electrician. This will help to identify any potential safety hazards and ensure that your electrical system is in good working order. By following these safety tips, you can help to protect yourself and others from the dangers of electricity. Electrical safety is everyone's responsibility. When evaluating an electrical system, it's important to understand the different types of electrical panels and their functions. The electrical panel, also known as the breaker box or fuse box, is the central distribution point for electricity in a building. It receives power from the utility company and distributes it to various circuits throughout the building. There are two main types of electrical panels: circuit breaker panels and fuse panels. Circuit breaker panels use circuit breakers to protect against overloads and short circuits. Circuit breakers are reusable devices that trip and interrupt the flow of electricity when a circuit is overloaded. Fuse panels use fuses to protect against overloads and short circuits. Fuses are one-time use devices that melt and interrupt the flow of electricity when a circuit is overloaded. Circuit breaker panels are generally considered to be safer and more convenient than fuse panels. Circuit breakers can be easily reset after they trip, while fuses must be replaced. Additionally, circuit breaker panels typically have a higher interrupting capacity than fuse panels, which means they can handle larger overloads without failing. When evaluating an electrical panel, it's important to consider its capacity, its condition, and its compliance with current codes. The capacity of the electrical panel refers to the amount of current it can safely handle. The capacity is typically measured in amps. The electrical panel should be sized to accommodate the electrical load of the building. If the panel is too small, it can become overloaded and pose a fire hazard. The condition of the electrical panel is also important to consider. Look for any signs of damage, such as rust, corrosion, or loose wires. A damaged electrical panel can be a safety hazard and should be repaired or replaced. The electrical panel should also be in compliance with current codes. This means that it should be properly grounded, have adequate overcurrent protection, and be installed in a safe location. If you're not sure whether your electrical panel is up to code, it's best to consult with a qualified electrician. They can inspect the panel and recommend any necessary repairs or upgrades. Upgrading an electrical panel can be a significant investment, but it's an important one to protect your home and family from electrical hazards. By ensuring that your electrical panel is properly sized, in good condition, and up to code, you can help to prevent electrical fires and other accidents. In addition to the electrical panel, it's also important to understand the different types of electrical circuits and their functions. An electrical circuit is a path that allows electricity to flow from a power source to an electrical device or appliance and back again. There are two main types of electrical circuits: branch circuits and feeder circuits. Branch circuits are the circuits that directly supply power to electrical devices and appliances. Feeder circuits are the circuits that supply power to branch circuits. Branch circuits are typically protected by circuit breakers or fuses in the electrical panel. The size of the circuit breaker or fuse is determined by the ampacity of the circuit. The ampacity is the amount of current the circuit can safely carry. Feeder circuits are typically larger than branch circuits and are used to supply power to multiple branch circuits or to a subpanel. A subpanel is a smaller electrical panel that is fed by a feeder circuit from the main electrical panel. Subpanels are often used in additions or renovations to provide additional circuits without having to upgrade the main electrical panel. When evaluating an electrical system, it's important to understand the different types of circuits and their functions. This will help you to identify any potential problems and ensure that your electrical system is working properly. In the specific scenario described, the use of a gutter to distribute power to the panels is not in accordance with the current National Electrical Code. A gutter is a metal trough that is used to enclose and protect electrical conductors. Gutters are typically used in industrial or commercial applications, but they are not permitted for use in residential wiring systems. The National Electrical Code requires that branch circuits be run in conduit, cable, or other approved wiring methods. Conduit is a metal or plastic tube that is used to protect electrical conductors. Cable is a group of insulated conductors that are enclosed in a sheath. There are many different types of electrical cables, such as non-metallic sheathed cable, armored cable, and mineral insulated cable. The type of wiring method that is used depends on the application and the local electrical codes. If you have a gutter in your home's electrical system, it's recommended to have it replaced with an approved wiring method. This will help to ensure the safety of your electrical system and bring it into compliance with the National Electrical Code. When upgrading an electrical system, it's important to consider the future electrical needs of the building. This means planning for any future additions, renovations, or electrical devices that may be added. It's also important to consider the energy efficiency of the electrical system. There are many ways to improve the energy efficiency of an electrical system, such as using energy-efficient lighting, appliances, and wiring methods. By planning for the future and improving the energy efficiency of your electrical system, you can save money on your energy bills and reduce your environmental impact. Electrical systems are complex and potentially dangerous. It's important to have a qualified electrician perform any electrical work. A qualified electrician will have the knowledge, skills, and experience to perform the work safely and in accordance with all applicable codes and regulations. Choosing a qualified electrician is an important step in protecting your home and family from electrical hazards.